Hey everyone, today we are solving LeetCode problem number 2225. Find players with 0 and 1 losses. Okay, in this problem we are given an integer array matches where every element in the matches array represents winner and the loser of that corresponding match. It means winner 1, winner I defeated the loser I. Okay, what we have to return is an answer list of size 2, where the first list will contain all the players that have not lost any matches, and the second list contains all the players that have lost exactly one matches. The value in the two lists should be returned in increasing order. Okay, so we have to return a list where we will have two lists in it. The first list is all the players who have lost zero matches, not lost any matches, and second list will be having list of all the players who have lost only one match, like T players with zero defeat, player with one defeat. And we are also given that we should return these two lists in the increasing order. You should only consider the player that have played at least one match. Okay, so if any player is not involved in any match, we won't consider that. The test case will be generated such that no two matches will have same outcomes. Okay, all the matches are unique, and we have to consider the player who have played any matches. I think this list is having players which are playing together, and first one is the winner, second one is the loser. So they must have played a game. That's why they are winner or loser. And what are the constraints? The matches dot length is 10 to the power 5, and the player value is going from 1 to 10 to the power 5. And winner and loser are not same. It means we will get a valid input. Okay, this has been asked in Indeed and Palantir Technologies. So what we are going to do is, how do we approach this problem? What is asked to us is that we have to return list containing two lists. First one is the losers with zero loss. I mean, they are the players with zero losses, and the player with one losses. Okay, so we have to return player with zero losses and one losses. So if we are given this problem, how do we approach that? Or at the first index of every subarray are the player who have lost the matches, and overall as a whole all the numbers are the player number who have played in a match. It means, let's say for the first one played a match, three played a match, where one is the loser and one is the winner and three is the loser, and so on. So if we have to find all the player who have lost zero matches, it means those player rank should not be at the second place. Okay, and player with one losses, it means all these second values in the subarray are the player who are losers. And what we can do is, if we count the frequency in frequency of the count, like ma- lo- lo- frequency of lost matches, we can find out this answer. So what we are going to do is, we will track our losers. So let's say for 3 we have 1 by the 1, and from the second we have 2 losses. For 6 we have 1 losses. For 6 now we have 2 losses. For 5, sorry, for 7 here we have 1 loss. For 5 again we have 1 loss. For 8 we have 1 loss. 9 with 1 defeat, and 4 with 1, and 9 again, so it will become 2. So what we have to return is the player with 1 losses only. So 7, 5, 8, 4. 7, 5, 8, 4 should be here. And also we are asked that this list should be sorted. So 4 should come first, then 5, then 7, then 8. So this should be our second list. And in our first list, what we have to track is these numbers at the first places are the player who are the winner, and these are the player who are the losers. So if any of the winner is not present in this list, it means that is the winner with 0 defeat. So that we can track here. So let's say one is not present here in this map, and after that 2 is also not present, 3 is present, 4 is present, 5, 6, 7, 8, 9 is also present, 10 is not present, 10 is here. So 10 is not present, and then yeah, we are done. So these are our players with 0 losses and 1 losses. So here what we did is we tracked the defeat count using a map, and after that from that map we check the frequencies. If the frequency is 1, it means these are the player with 1 losses, and these player we can add in this list, the first list with 1 losses. Okay, and after that, how do we track the 0 losses? All of these winners who are not in this list, not in this map, those are the winners or losers with 0 losses. I think I mean player with 0 losses. So what do we do now? We track using this. For that, what we can consider is a set, that all of these elements will be added to the set, and then we will remove set minus key set of this map. So this will also give me all the players with 0 losses. That is also fine. So for that, if we use that approach, if we use a map and set, in that case for map we are storing the map, storing the set, our time complexity will go to what extent on till this set, on till this map, but after adding here we are sorting the elements, so the time complexity will go till order of n log n. And what is the space complexity? 2 into n, which is order of n. This is time, this is space of our approach where we will use map or set. But here if we try to understand again that we are using extra set, and in that set we are removing that key set, but instead of set, why don't we just add these element as well in this map? So instead, along with these elements, if I add these winning element as well, so what I would do is I will add my winner and loser as well. So if while doing addition of the winner, I will check whether the entry is already present or not. If the entry is not present, what I will do is I will put winner with 0. Okay. If the entry is not present, it means the loser is having 1 loss and the winner is having 0 loss. So for the winner, let's say we have 1 comma 3 as our set. So what I will put is 1 is winner and 3 is loser. So for the winner, what I can put is put winner comma 0. If these are not present in the map, if these are already present, if the winner is already present, then also we don't have to do anything. Yeah, if winner is already present, we have to check whether the winner value is not equal to 0 or not, or maybe greater than 0 or not. If it is greater than 0, it means this is the number of losses. So for the map, what I would track is player ID and number of losses. So player is W, which is 3 1, and number of losses is 0. For the loser as well, what I will do is put L if it is the first entry. In that case, I will add 1. So for the first entry, we are adding 0 or 1 as well. So it means we have to initialize our map with some initialize. We cannot initialize our values with 0 or something like that. So if we are going to take an array, let's try to discuss it with a map approach first. So we have taken a map where it is the player and the number of losses. So for while adding the winner, I will check whether if map.getValue is not equal to 0, it means this winner has already been a loser. It means we won't do anything. We will keep the existing value in it. So what I will do is what map dot put. Okay, what is our key? Key is W for the winner. So map dot get or default get the existing value or the default value. Let's say for our winner, the existing value is there is no existing value. In that case, what we have to enter is we have to enter that this is a winner and 0 losses. So default value should be 0. If it is non-zero, that we already have 1, 2, 3, something like that. In that case, it has already been a loser, so it won't affect our entry. So it will remain like this. The map dot get value of W. So this should be our entry in case of winner, and what in case of loser. Map dot put, this is L for loser. Let's say for our example, 1 was winner, L 3 was loser. Map dot put loser. For loser, what we have to do is we have to just append the number of losses. If it is the first entry, we are going to add 1. If it is the 1 to the 0, if it is the existing entry that we already have loser count 2, in that case it will remain going from 2 to 3. So existing value plus 1. So either existing value or the default value, which is 0. So map get or default existing value or default value 0 plus 1. We are adding 1 to the losses. So this is our loser value. So after that, we have all the entries in the map. So player with 0 losses will have key value equal to 0. Player with 1 losses will have value equal to 1. So we can directly iterate over map, or we can add it to our 0 list and 1 list. Okay, I hope that is clear to you. But here, what is the issue is that this list is not sorted. So if we are going to sort that list, it will go n log n. So that's why till this moment it was log of n. Sorry, order of n. Here also it is order of n. We are iterating the map. So ultimately time was order of n, but in the end it has become n log n, which is bigger than order of n. So for this approach, time complexity is order of and log n, and what is the space complexity is in the order of n. But this is not the most efficient approach, because as we used map, we are not able to store it in the sorted form. But in the constraints, like let's call it approach 2, in the constraints we are given that player I, let's say, or the winner or the loser value will go till 10 power 5 and greater than equal to 1. So this is the constraint for our winner or loser. Let's say player with ID, where ID is I and I is going from 1 to 10 power 5. So if we take an array and we store the number of losses on the indices, index is 0, 1, 2, 3 till 10 power 5. This is the array, and what we are going to store is number of losses. Number of losses can be 0, 1, or greater than equal to 1. These can be the value. So what should be the predefined value in this? Apart from this, let's call it -1. Let's say we have initialized our array with -1. Now what we have to do is we will iterate over our input again. Let's call it, let's say first value was 1, 3, then 2, 5, and so on. These are our matches. So first value is winner, second value is loser. So what I would see is I will check whether the winner value can be -1 or not equal to -1. If it is already -1, it means this is the first time this player is playing a match and it is the winner. So from -1 it will become 0. Okay. And if it is not equal to -1, it means this is not the actual winner and this player has already lost some matches. So just discard this call. So for the loser, what we have to do, what a loser value can be, it can be -1 in the starting or not equal to -1. So in case of -1, we have to put 1 because this is the first match of this loser and this has become a real loser by losing this match. Okay. So yeah, if it is the first loss, then it is 1. Otherwise, if it is not equal to -1, it means this player has already lost some matches. So the existing value, previous value plus 1, which is array of I plus plus. So we got three possibility. So first possibility is this, second possibility is this, third possibility is this. Okay. So how do we write the call? If array of winner equal to -1, in that case we have to do something. We have to put array of w is equal to 0. So this is for winner. So this call is done. Now for this call is for loser. If array of loser, which is second part, this was for 1, this was for 3. Array of loser is equal to -1. In that case, make array of L equal to 1, first clause. Else if, or just directly use else. If it is -1, in that case it is 1. Else array of L plus plus. So this is in case of loser. So but what benefit do we get here is that we are storing these values in sorting form. So after this call, we have our array initialized with number of losses. from 0, 1, 2, 3, 4 till 10 to the power 5, and we can iterate for I equal to 1 because player ID is going from 1 to 10 to the power 5 combined both. I equal to 1 till I less than equal to 10 to the power 5. If array of I player I is having 0 losses, add to the 0 list. If array of I is equal to 1 losses, add to the 1 list. Now both of our lists are prepared, but those lists are in sorted form because we are iterating player from 1 to 10 to the power 5 in the increasing order. So here till this preparation of our hash array, it is order of n. Iterating this hash array again and preparing the list, still it is order of n, and now we don't have to do any kind of sorting, so the time complexity is finally improved to order of n. Space complexity will also remain order of n. So this is the highly optimized approach where we are able to solve this problem in the order of n. Okay, now let's have a look at the code. Here what I have done is, first of all, let me full screen this. This is my first function where I have used hash map. So while iterating over these matches, I have added it to the hash map. After that, I prepared two lists, and if the match key is 0, I have added to the 0 list, then add to the 1 list. But after that, there was an overhead of sorting both of these lists. So that's why it was going n log n. But later on, we did the hash. We took the hash array where we were storing the number of losses of the player against its index. So for the player with id 10 to the power 5, we are able to store in this array. Initially I am initializing it with -1 because the hash value can also be 0. So now I am also iterating over our matches. This is a winner, this is the loser, and if the winner is -1, it means the player is playing the game for the first time and it is the winner. It means we can easily put the hash value to 0. Otherwise we don't have to do anything. And now if it is a loser, what I am going to do is, if hash value is -1, it means that this is the first loss of the player. In that case, we can put the hash value to 1. Otherwise, the value can be 1, 2, 3, or it can also be 0, that it is the winner from the previous match. Now it has lost the match. So in all the cases, we can directly append 1 or maybe increment by 1. So now it will be storing total number of losses against each player. Now we have our array ready. From our array, what we can do is we can iterate from 1 to 10 to the power 5. If the hash value is 0, add to the 0 list. Hash value is 1, add to the 1 list, and ultimately return our answer. So this is our final approach, find winners. Let's also try to submit it. Here's the result, beats 93% of the Java. So this is highly approach. Maybe the previous solution was here somewhere because that was n log n, and this is the on approach. Okay, hope you understood the problem. Thank you guys.